Hello students, in this video we will discuss about layout of thermal power plant. The diagram shows the layout of a typical thermal power plant. Coal is the main source of input for the thermal power plant. The coal is stored in the coal storage plant. From the coal storage, the coal is moved to the coal handling plant through conveyor belts. In coal handling plants, we will have coal hopper and the pulverizer. Pulverizer is used to powder the coal and then the powdered coal is fed into the boiler. Boiler is the device in which the water is heated and the steam is produced. The produced steam from the boiler is given to the superheater in which the temperature of the steam is further increased. The high pressure and high temperature steam is given to the turbine through a valve. In the turbine, the steam is getting expanded and the mechanical rotations are produced. The turbine is coupled with alternator, which is actually a three-phase generator. The three-phase generator or alternator converts the output mechanical energy of the turbine into electrical energy. The output of the alternator is connected to the transformer to increase the voltage level. Then the high voltage is connected to the bus bars through isolators and circuit breakers. The alternator requires DC supply to produce magnetic flux. For that, we have a small DC generator coupled with the alternator, which is called exciter. Now, let us come to the turbine part. In the turbine, the steam is getting expanded. After the expansion, the exhaust steam is given to the condenser. The exhaust steam is given to the condenser. In the condenser, the steam is cooled and then again it is converted into water. This condenser output is given to the cooling tower. In the cooling tower, the water from the river is taken and the temperature of the water which is circulated in the condenser is getting reduced. So this is ensured by means of circulating water pump. So I repeat the operation once again. The exhaust steam is given to the condenser. In the condenser, the exhaust steam is passed through tubes and then it is cooled with water. That water is going to absorb the temperature of the exhaust steam and then the water is circulated through the cooling tower. In the cooling tower, the river water or the fresh water is used to cool the circulating water. Then again, after reducing the temperature of the circulating water pump is used to pump the water again to the condenser. The condensed exhaust steam is again pumped into the system through condensate extraction pump. Okay, so this is the condensate extract pump. Suppose if the water is to be included in the circuit for the heating process, the water is taken from the river and through the water treatment chamber, it is given to the feed water pump. So the feed water pump is going to take the water either from the condenser output or from the water treatment chamber. From this, the feed water pump pumps the water inside the feed water heater. Feed water heater is used to heat the water which is fed into the boiler. And from the feed water heater, the water goes to the economizer. So economizer is the arrangement which is used to extract the heat from the flue gases. Okay. After the economizer, the water is fed into the boiler. So while entering the boiler, the water would have acquired some temperature. This is being done from the extraction of heat from the flue gases. To make the boiler working, we need to force the air inside the boiler for the combustion process. For that, the forced draft fan is used. The forced draft fan is going to force the atmospheric air inside the boiler. While forcing the air inside the boiler, it is made to pass through air preheater. Air preheater is the arrangement where the further the heat present in the flue gases will be absorbed by the feed air fed into the boiler. The temperature of the air fed into the boiler is increased, which is denoted here as a hot air, which increases or which has more capacity to fire the fuel. After this, the flue gas is given to the induced draft fan and then it is forced to escape to the atmospheric air through the chimney. When we look into the output flue gases circuit from the boiler after the coal is being burnt, the flue gases are first passed through the superheater, in which the most of the heat is being absorbed by the steam and then the steam is coming out as a superheated steam. The rest of the temperature or the heat present in the gas will be taken out by the economizer, which is going to heat the feed water. Further, the temperature heat available in the flue gas will be extracted by the air preheater to heat up the air fed into the boiler. Now let us come back to the boiler. From the boiler, the wastage, the ash will be given to the ash handling plant. So here we will be having the electrostatic precipitator and other arrangements to handle the ash. Once if it is being separated, it will be given to the ash storage. Normally it will be dissolved in the water and then given to the ash storage plant. So this is the total overall arrangement of a thermal power plant. Normally the thermal power plants are situated in a remote place where the temperature, where the water availability is available. Mostly it will be nearby a dam or river. This is the overall block diagram of the thermal power plant. For individual blocks, please refer to other videos in the playlist. Thank you for watching.